Hello grade 12s, welcome to my channel. Let us have a look at this question. It's on analytical geometry. This is, some very good easy marks to score in paper 2. But some questions can be quite a nightmare. So it helps to understand the depth of the subject so that when easy questions come, they are easy to chew on. But when difficult ones come, they're also very manageable. Now let's have a look at this question and just gather some thoughts, and I will highlight some notes for you students to keep. Now question 13 reads, in the diagram below, center W of the circle lies on the straight line. Now this straight line is written in a way that I don't like. I often prefer to isolate y here. So this becomes minus 3 over 4 x minus 7 over 4. Of course, it's not a big deal, but I like this format, especially on the Cartesian plane. Now, we were told that this is the center, okay? So this is good. Now the straight line cuts the circle at V. No mention of those coordinates. So point V is a potential question. So we need to think about ways in which we can solve that conundrum. And Z with coordinates of -1 and -1. Okay, that's evident. Now the circle touches. Now that statement, once we hear that word, we know that if the circle touches the y-axis, remember the y-axis is a straight line. It's not just anything. The y-axis are essentially a straight line. So if a straight line touches a curve at just one point, what does this mean? It means the y-axis becomes a tangent to the circle at that point G with 0 and 2. Alright, so once we have everything understood, we should start interpreting the diagram with the piece of information given to us. Nothing else. Don't look at the questions. Don't rush into anything. Of course, during practice. Now we will know that if this is tangential to the circle, it means any line drawn from the center to that line should be perpendicular to the tangent. Right. So now this was not a line given, so we have to dash it a bit because we are imagining this. But now how does this help us? It tells us that if this line is perpendicular to the y-axis, there's something I don't know. Sometimes there are certain things that irritate me. I don't know, my pen no longer points well. Anyway, whatever. We will understand that if this line WG is perpendicular to the y-axis, it must be parallel to the x-axis. Right? Because the x-axis are themselves perpendicular to the y-axis. Now this makes the line WG a horizontal line. Now on a horizontal line, the y value is the same at any point along that line. And we can see W is along that line. So this essentially helps us to then know that the y value at W is 2. But the x value still remains a mystery. Okay, so that's the little bit that we can do. And we know that this x value is perfectly a horizontal line. A point horizontally from the origin that way. And this would give us the radius r. It's going to be the absolute value of the x coordinate of W. Maybe let me put it that way. Right. So the radius here is literally the absolute value of whatever value x is at w. Okay, so you probably are not familiar with these notations, but I would love to introduce you to these things, guys. So that you know. I don't know what I just wrote there. Yeah. But my W doesn't want to write nicely. Hey, wena. Okay, so this is just me trying to be too much, I guess. But you've got to understand these things. Right. So that's what we have. So question is, how will we find this x value at w? Now we will see that we have found the y value. That the y value of g is the same as the y value of w. But there's a line or a vector that passes through w, which is this one right here. So this means we can substitute the y value into that equation and solve for the corresponding x value. So we have a plan for that x coordinate of w. Now, once we have that done, what about v? How will we find v? We will appreciate that v is the point of intersection of the circle and the straight line. And this means we need to determine the equation of the circle, which we will, because effectively finding the x coordinate at w is as good as finding the radius of this circle. So we'll have a full equation of the circle. Then we substitute y in terms of that there. That will solve for x. Of course, it will give us two values. One that would be at z, which is -1, and one that would be at v. Okay? And we solve for the corresponding y values. One will be the one at z, and the other one would be the one at v. So that's the plan. So we've got a plan for this business right here. So it means we are in a position to do a lot. But what is the easier way to do this? Because remember, guys, you've got to explore every little detail. We know that we can use symmetry if we can know the coordinates of w. Since this is a circle, we can use symmetry and say, look, if we draw a line from w right into this other line, right, we will be able to know by how much, because remember these collinear points on a circle like this, because of the radii being equal, it will tell us that we literally have moved point z along this line to w. So how did we do it? We were sitting at -1 vertically. Now we are at 2. So what is that? That's 3 units. So this means we moved point z 3 units upward to get to w. Then if we find the x coordinate, it will tell us by how much did we move this x coordinate horizontally to the left. And if that's the case, it means the same way we will be able to move w to v. Okay? So in a similar manner, we will be able to move w to v. So this is what this means, guys. Very easy stuff, not too complex. Again, we will see that if we moved vertically 3 units, we literally are going to still move 3 units vertically. So this tells us that this y value right here is going to be 2 plus 3, which gives us 5. Now, depending on what the x value is at w, we will then be able to find the x at v. So this is very helpful to always look, not rush into anything, and then get to business. All right. So it seems like we are able to solve almost everything that we see in our sketch. So what we can do now is to answer the questions. Remember, if you cannot answer everything, think of ways in which that would work so that you can recognize perhaps the necessary piece of information that is probably not given as yet. Then that helps to skim and scan the questions to find out if you can answer all those questions. Because at times, whatever seems missing may be the next question. And you don't want it to give you some fright when it becomes challenging. So once you have a plan, it makes it very easy to know what to do once more information is provided. Okay guys, so this is as easy as it looks. So since we see that everything looks answerable, then we can just get into these questions one by one. So 13.1.1, we are asked to determine the equation of the circle in the standard format. Okay, great. So we know that we need the center because finding that x-coordinate of the center is as good as solving this. But we need to say some serious things. We should know that W is such that y at W is going to be equal to y at G. Why do we know this? We know that basically the tangent is always perpendicular to radius. Okay, such that WG is a horizontal line. Now, on a horizontal line, we know that the y value is the same. So what does this mean? It simply means that y at W is 2. Very important. We can say also, we know that with that equation 3x plus 4y plus 7 equal to 0, when we substitute Wx is to 2, we get 3x plus 4 into 2 plus 7 equal to 0. This implies that 3x equals, this is 8 plus 7, that's 15. We transpose, it becomes minus 15. Therefore, our x here is minus 5. So this also concludes that W is the point minus 5 is to 2. So can you see a systematic approach, guys, not just dropping from the sky. We justify things in the best possible way. Remember, in the best possible way. Don't fixate too much on what I have said, what the memorandum is going to say. Rather express yourself in the best possible way that you can. And remember, whatever you do has to be some kind of an attempt in the right direction that mathematics approves of. Don't do things that are illegal in mathematics. Now we have this situation, right? Right. And we have stated stuff here that WG is a horizontal line. So this is very key in answering the question finally. Then we will understand that our circle W is given by x minus the x coordinate of W is going to be minus 5, which becomes plus 5 all squared into y minus the y value at W. It's going to be 2 all squared equals. Now since we said WG gives us the radius, we know that the x at G is 0 minus the x at W is going to be minus 5, which becomes plus 5, and then we square that. So we can say, therefore, the circle W is given by x plus 5 all squared plus y minus 2 all squared equals 25. So a nice and easy question to answer, provided we understood everything from inspection and taking time to understand the diagram in the best possible way. For me, this is very important, as well as this is very important. And essentially the left-hand side and the right-hand side and the final equation in the required format. So that covers the 5 marks on offer. 13.1.2. We are asked to determine the length of diameter VZ. Easy. So it's just 1 mark, so this means an answer only is important. So we see that the radius is going to be the square root of 25. And essentially, this doubled is going to give us 10. So we can just say VZ is equal to 10 units. Nice and easy. So an answer only here is easy because even the question says determine. So it's an open-ended question. We can do it by inspection or follow some rules. Of course, a student who wants to answer in a more complete way, which is okay, but sometimes don't waste time. We can say VZ is going to be 2 times the square root of 25, right? Which will conclude that VZ is going to be 10 units. Okay? But you see here, showing the steps is not really that very big a deal. There are some questions that you will see that the examination is not on the method but rather on the answer. So again, practicing long enough will help you determine this without even doubting yourself. Again, this is, just to show you guys the systematic approach to this, but the value of this question is also an important thing to take note of to avoid wasting time. Question says calculate the gradient of GZ. Now here we can't just show up with an answer. We still have to show the systematic approach to it, irrespective of the marks. Because remember, the instruction is the question. The marks are an indication of, if a question is an open-ended one, how much do you have to work for that? But if it is directive like calculate, there's no way we should not see a calculation. Alright, so the gradient of GZ is going to be equal to y at Z minus y at G divided by x at Z minus x at G. Okay, so this implies that y at Z is minus 1 minus y at G, which is going to be minus 2, divided by x at Z is minus 1 minus x at G, which is 0. This is effectively 3, right? Right. Great stuff. So marks are for the substitution and the answer. And remember, the substitution only gets full marks if we see the formula. Yes, it is not mark worthy, but it helps to mark the substitutions, without which the substitutions lose a mark. So remember guys, you may find yourself scoring just 1 mark for the correct answer. It can happen, okay? Because when we just see a substitution and an answer, it's giving the vibes that you actually are copying from someone else. You didn't have enough time to copy the formula. Why? Because the instructions are very clear at the beginning that for all workings, everything has to be shown clearly, right? There's that etc. part. Many people miss that component and they end up fluffing a very easy exam just by being careless. All right, so the next one says we need to write down the coordinates of the midpoint of GZ. Now when the question says write down, again, this is a directive that no silly calculations are to be shown here. So it means you do it on the rough work and then sort it out. Okay, so we have 13.1.4. What I would say, let the midpoint of GZ be H. Okay, such that H is going to be, we will see that we just add, because remember it's quite a very steep line connecting those two. Just show it nicely. Yeah. It's a very steep line. So there it is. Now we want the midpoint. If we just try and approximate it, it could be something like there. Maybe not. Here, that's a bit better. Yeah, we can say that our H is over there. All right. So we expect this to be somewhat in the second quadrant, meaning the x coordinate should be negative while the y coordinate is positive. Now let's see, we just simply add the x coordinates together and then divide by 2. So 0 plus minus 1 is just minus 1. Divided by 2, it's minus a half. Next one, we will take the average also of the y values. So 2 minus 1, it's 1. Divided by 2, it's just a half. Okay, so this is it. This is it. So we get our 1 mark. Normally this should be 2 marks, I guess, because we have determined 2 things, but it seems like the examiners were not interested in that business. Of course, we can indicate that these are equal. Please annotate the sketch freely, guys, but in a clean way so that no one struggles to follow what you are doing. 13.1.5. We then have to determine the equation of the line that is the perpendicular bisector of GZ. Okay, so what do we know? Remember, this line GZ is a chord of the circle. Now, any perpendicular bisector of a chord of a circle essentially passes through the center of the circle. Right? We should know. Skampaphela wena man. Onkera biana biano. Waning onkera so man. Skanketsa jwalo man. So a perpendicular bisector of a chord of any circle will always pass through the center of the circle. That's from theorem 1, isn't it? Remember that. We're just stating it differently, which is convenient at this point to do so, but yeah, that's the idea. So now we can use W as the other point, and of course get the gradient by using GZ. So it's very easy. So you can just say the gradient of the line is going to be equal to minus the negative reciprocal of the gradient of GZ. Now that was 3, so this is going to be 1 over 3. Okay, so we may want to justify this, that the gradient of the line multiplied by the gradient of GZ should give us minus 1. This is from that statement. Well, you can either write it down and justify it, or write this rule and then solve, and eventually it will get us to where we need to go. We can say then the line is such that y is equal to minus a third of x plus c. Now we can take h, since we have it, with h with minus a half is to a half it is such that a half is equal to minus a third into minus a half plus c. So therefore c is equal to, now this is going to be plus 1 over 6. When we take it over, 6 divides 2 by 3. 3 times the numerator is 1, is basically 3, right? And then 3 minus 1 is going to be just 2. And over 6, that's a third. Okay, so we have a third here. Of course, guys, you can punch this in the calculator. Don't torture yourself too much if you're not so comfortable with this, but at times allow the brain to stay awake so that you don't shut it off completely. So this is the equation of our line. Does it make sense? Well, if we produce our line, if we produce our line, we can appreciate that this line actually, okay, let's not make it too complicated. We will appreciate that its y-intercept is there. That's good enough for a third. So we are home free. We are home free. So nice and easy. Nice and easy. All right, so this looks okay. So of course, guys, the gradient is key. Substituting any point to determine c is key, and then writing the equation in the required format is how we score the full 3 marks for that question. All right, so we have 13.1.6. Now this says we need to show that the line in question 4, can you see this was rather from a question 4, and now they decided to write it 13. How strange, okay? And the straight line VZ intersect at W. Okay, now there's many ways to say this. I mean, it's just 2 marks. So what I would say, I would just say the line y equals minus 1 over 3x plus 1 over 3 passes through W. Why do I know this? It's because a perpendicular bisector of a chord passes through the center of a circle. All right, that's a proper show, because we just say it and then justify it. So the justification is core, because I mean the line VZ already passes through the center. We were told. There's no need to explain that. So one can just use the theorem here, but in a manner that is conducive for the question at hand. Or alternatively, one may want to just show that basically if we are to solve VZ is equal to the line, let's just say it VZ is equal to line, right? Because when they are equal, this is what it means. So this implies, now the equation for VZ, when we sorted it out, it was basically minus 3 over 4 x minus 7 over 4 is equal to, this line is going to be minus a third plus a third. Okay, that was supposed to be x. Then we just solve for x. Easy. So what do we do here? We just take this to the other side. A third minus 3/4 is basically, is it going to be a third? Let me see. Minus 3/4 plus a third. At times you just don't want to abuse that brain. So we get something else. So this is minus 5 over 12. X equals, then we take a third and we add 7/4. So a third plus 7/4. It gives us 25/12. Right, 25/12. Therefore, we understand that x is going to be, now when we divide by this flipped, the 12 will literally divide to 1, and then 25 divided by 5 is going to be minus 5. Do you see that the x value there is that 1? So let's see, therefore y is going to be basically minus 3/4 of minus 5 minus 7/4. Now what does that give us? Now this becomes 15 over 4. Now 15 minus 7 is 8. 8 divided by 4, that's a 2. So can you see? Therefore we can see that W with minus 5 is to 2 is the point of intersection of VZ and the line. Nice. We are done. Of course, as you can see, this is a bigger show, and nobody said don't do it. It's very important. So what does this mean? It's just to perhaps solve simultaneously here. The conclusion has already been stated, but I think uncovering these two, although we know, we honestly do know, but yeah, that's the idea. Even those values for me are perhaps too weak, but I guess solving side by side and the substitutions there, they kind of constitute a show that this thing will boil down to exactly what we just did there. Now the other thing one could easily do is to substitute W to both equations. That's another way of showing that this is going to be the case. So we will take W minus 5 and 2 into y equals, in fact we can even write it as it was given, say into 3x plus 4y plus 7 is equal to 0. And we do the same. Take W with minus 5 and 2 into that equation that we solved. Y equals minus 1 over 3 of x plus a third. Okay? If the left-hand side is equal to the right-hand side, and the same here, are equal, therefore W is a common point. All right. So we can easily say that would be the case. So guys, this is your part to play, okay? Do it for completeness sakes. I cannot do it all, but this is how one should answer a question like this. All right. So all you do, you take that very point W, you substitute into both equations. If the left-hand side balances the right-hand side, it means W is a point in that line. So there's many ways of doing that. As you can see, this is also just as labor intensive as the other one of solving simultaneously. But a student who's confident in the subject can just use theorem 1 to just sort the mess without struggling, because that's good enough as well. All right, so let's get to 13.2. Now 13.2 says the circle defined by x plus 2 all squared plus y minus 1 all squared equals 25. Of note is that the radius of this circle is the same as the radius of the circle we were given at 13.1. Has the center M, okay? And the circle defined by x minus 1 all squared plus y minus 3 all squared equals 9 has the center N, okay? No problem. Now the question says, show that the circles intersect each other at 2 distinct points. So this simply says question 13 is different from 13.1. Although that 25 wanted to catch us, but it's actually not part of this question. Okay, it's a different question altogether. Of course, guys, if we look at these circles, what would be the center here? M is going to be minus 2:1. So this is in the second quadrant, and the radius here is going to be 5. The second one, we know that N is going to be 1 and 3. So this is the point in the first quadrant, and R is going to be 3 units. Okay, easy stuff. So this is something like that. This one is a bit bigger, and then a smaller circle. Now what we can do, we need to show that these do this. Of course, this one is a bit higher, but just looking at those coordinates, if I can just try to put it here. Okay, so this is how these circles are meant to intersect. And of course, we can say the center is approximately there. So this is M with the coordinates minus 2 and 1. And the center for this one is approximately there. So that is N with 1 and 3. All right, so that's it. We are happy with what we have. But now, how do we demonstrate that these two intersect at 2 distinct points? It's very easy, because all we need to do is to calculate this distance between the centers. If that distance between the centers is essentially greater than the sum of the radii, right? Because we've got a radius here going this way. Or maybe let me choose a different direction. We've got a radius there. And we have a radius there too. Okay, maybe let's leave this. So all we need to do is to calculate that distance between the centers and calculate the sum of the radii as well as the difference of the radii. If that distance falls between the difference of the radii and the sum of the radii, it then tells us that those two circles will intersect at 2 distinct points. It's a very naughty question, but one that we can handle. So let's see. We first want to know that Mn from the distance formula It's going to be x at n minus x at m, all squared y at n minus y at m, all squared. So x at n is 1, and y at, x, there's going to be minus 2, that's going to be 2, all squared, plus, there we have 1 minus, no, what am I doing? This is 3 minus 1, all squared. Let's see, what do we have there? So that's going to be 9 plus 4, which is 13. So this is basically square root 13. It's irrational. Okay, root 13, and then of course then the nearest, or should we say the closest perfect square here before 13 is going to be 9. So this is going to be 3 comma something. We never look for the one ahead, the one before. All right. So what else can we do? We then calculate the sum of the radii. We can say also, we know that the radius of m plus the radius of n is going to be 5 plus 3, right, which is equal to 8 units. Right. Now, why are we exploring this, guys? It's because if these two circles were to sit something like that, if these circles were to sit like this so that they touch at only one point, now we will see that the radius, the center is almost there. Center is almost there. We will see that the radius of the other circle, basically the radius all the way there, and the radius of the other one all the way there. Can you see this mn would literally be the radii added together. Right, so this whole shenanigan is coming from this restriction that, okay, we know that if these circles were to touch at only one point externally, then the distance between their centers would literally be the sum of their radii. This is what we are trying to exclude. We can say likewise, I don't know if it is likewise or is it different, but let's just say likewise, or perhaps however. Maybe let's just say however. And maybe we can say what? Also, but. Maybe this is better to say but here. Even if we said it next, we can say also. We want to know that the radius Rm minus the radius Rn is going to be equal to 5 minus 3, which is equal to 2 units. Right. Now, why are we thinking about it that way? Well, this is because we have to consider again another situation when these two circles touch each other, let's just say at one point internally. Right. We know that this is approximately the radius of the bigger one. This is approximately the radius of the smaller one. Okay? So this is M, this is N. Now, what we appreciate is that the radius of the bigger one and the radius of the smaller one are like that now. And can you see that MN is literally the difference between the radii? So this is basically why we think about that. Because we'll see that the distance between these two centers is literally the difference between the radii when they touch internally at one point. Now we can say, therefore, MN is less than the sum of the radii, but greater than the difference of the radii. And if this is the case, maybe let's put this one rather later. We will say here, this implies that essentially root 13, we know that root 13 is 3 comma something, is certainly less than 8 and greater than 2. And that conclusion will lead us to saying, therefore, the two circles touch, or should we say intersect rather, intersect at two other points, or two distinct points. Let's put it the way we were given. So the two circles intersect intersect at two distinct points. Okay, that's it, guys. What makes it the case is this situation. When we prove that the distance between their centers fall between the sum of the radii and the difference of the radii. And we need to understand that those are the restrictions for this to be the case. All right. So those are the things we need to eliminate, as you can see through our schematic diagrams, as to why we pursue those things. All right. Very interesting stuff otherwise. Right, so this was 6 marks. How do we score these? Well, substitutions into the formula and solving this and getting this and that. So 1, 2, 3, 4. And of course, this conclusion right here. And of course, I don't know if this is mark worthy or this one, whatever, guys. At the end of the day, when work is done properly, the marks simply fall into place. So this is basically that one. Okay, please make sure you label these correctly. Now the question says, determine the equation of the common chord. Now this is a strange question, right? Many of you don't know how to handle this. Well, it's not a very difficult question to answer anyways. How do we deal with this? Now, this is the situation that we are talking about. Now, how will we find the common chord? So let's say there is the chord from that point of intersection to that point. So there is the common chord. So my students intrigued me. They were like, this chord is going to be perpendicular to the line that joins their centers. The question is why? Why is it the case? Well, if you think about it, guys, remember constructions. If we take it from the point of intersection to the center of the smaller circle, same way like that, what are we going to end up with? Well, we end up with this line equaling that line. Why? Because these are ready. And if we do the same and take it from that point of intersection to the center of the other one, like that, what do we end up with, folks? Well, we end up with a similar situation when that is equal to that. Again, those are ready. But look at the quadrilateral we just formed. It's a kite, because any quadrilateral that has two adjacent sides that are equal to each other in that manner, it makes it a kite. And so what do we know about a kite? The diagonals of a kite bisect each other. Not bisect, but intersect each other at 90 degrees. 2, the longer diagonal essentially cuts the shorter diagonal in half. It bisects it. Right. Again, this goes back to now saying line from center perpendicular to chord bisects the chord. More like that. Can you see, guys? This is exactly why it is so. At the time my students were answering, they were actually guessing. But technically they were guessing in the right direction because they had the right knowledge. So they were able to just approximate that knowledge to the right thing. And this is exactly the reason. So now please don't forget this. This is how this can work. Now obviously, folks, this is to suggest that if we can find the gradient of Mn, we literally will have the gradient of our common chord. So we will know that, of course, the gradient of our common chord, I'm just going to say Cc, multiplied by the gradient of Nm, we should get -1 because those two are perpendicular. As we can see, when we complete a quadrilateral on those points of intersections together with their centers, we form a kite. So this implies that MCC into, now the common chord, we saw that the point is basically 3 minus 1 divided by 1 minus minus. It's going to be like that, equals -1. Now you would be asking me, why am I just jumping for substitutions? Because somewhere in my calculations, I have determined the gradient and I have done it the standard way. So there's no way you can say I'm copying here if I'm performing a similar maneuver, because somewhere in this question, I answered to show that I understood what to do. Now I can jump in. But if I did not show this anyway, it is illegal to just jump in, okay? These are some of the things, guys, you want to note, okay? Please note these things. This is what gives you the confidence to do what you do. So this implies that MCC, which is the common chord, into, this becomes 2 over 4. Now 2 over 4, what did I do here? What did I do? I took the 3 there, right? I took the 3 and subtract the 1, so that's a 2. Yeah, there was a mistake here. There's no 3 here. There's a 2 instead, okay? So this is basically 2 over 3 equals -1. Therefore, the gradient of our common chord is basically going to be the negative reciprocal of this. It switches around. Right. So guys, so the students would say now, therefore, we understand that the common chord the common chord CC, just so that everybody understands, is such that y is equal to minus 3 over 2 x plus c. And then of course, guys, it would be like, how am I going to find this c? Well, it's not so easy, right? Not at all. But if you're a student and you stop here, remember, out of 3 marks, how much would you get? You would essentially get, because remember, this gradient was not asked, so it's a mark on its own. This is a mark, so you would get 2 marks at best. Now, solving for C is not really a big deal. I suppose this would be 4 marks rather than 3, you know. But let's say it's just for 3 marks. But that other gradient is a key to success, so it has to get a mark. And therefore, the final gradient also gets a mark. Then it means the final answer is what is important, which means it's just literally getting the C. Now you'd get 2 out of 3, because I mean, this is good enough. This is good enough. So my students kind of stopped here together with me when we solved this problem. But it turns out, well, we tried something to solve for the C, because we were like, look, these are the points of intersections between the 2 circles, you know. So now the points of intersections between the 2 circles, you know, those are the things we can actually handle. But here's the problem with this. Problem with this is, if you solve for y, it becomes complex, because normally we understand that we can just solve for y and then substitute the one circle into the other. It just doesn't work so well. So it kind of overwhelmed us that way. But what do we know, guys? We know that here, somebody may say, but we know that technically circle N or M is essentially equal to circle, goodness, what is this thing doing? It's equal to circle N, right? Because they share a common point of intersection. So what is the best thing to do here? The best thing to do is to know that circle M can be written like x plus 2 all squared plus y minus 1 all squared. Transpose the 25 equal to 0, right? And circle N can also be written as x minus 1 all squared plus y minus 3 all squared minus 9 equal to 0. Now, that is the best way to deal with issues here, because if this is 0 and that is 0, and we know these ones are going to be equal, kid refuses to highlight, this tells us that we can actually put them side by side. So this implies that whatever this is basically equal to whatever the other one is. Right, so this is what this means. Now we just FOIL stuff out. So this is x squared plus 4x plus 4 plus y squared minus 2y plus 1 minus 25 equals x squared minus 2x plus 1 plus y squared minus 6y plus 9 minus 9. Okay, so these ones immediately take care of each other. This takes care of that. That takes care of that. We end up with, so this is 4x. In fact, since this is 4x plus 2x, it gives us 6x, right? When we handle these two. And then we've got minus 2y plus 6y. When we transpose it to this side, it becomes plus 4y, right? And then we've got 4 plus 1, that's basically 5. Right, so we've got 5 minus 25, that's just minus 20. And if we minus 20 minus 1 is going to be minus 21. Of course, this is when we take care of this, this, that, and that is equal to 0. And now here's the issue. We are unable to solve, right? We are unable to solve because look, we don't win. But watch the magic here. This also implies if we isolate y here to make it the subject so that we can perhaps think of another equation we need to find. So we'll have 4y equals minus 6x plus 21. Now we divide. We'll say y is equal to minus, this is 6, not 3. So this is minus 6x over 4 plus 21 over 4. And we can simplify further this thing. 2 goes there, minus 3 divided by 2x plus here we cannot do anything. But watch this. Gradient. So this must be the c that we're looking for. So this actually gives us the equation of the common chord. So the equation of the common chord is basically the difference between the equations of the two circles. So essentially this is how to go about business here. As you can see, a student would thought by solving here for essentially the points of intersections, you end up getting the equation of the common chord rather. So it follows that the equation of common is given by, let's just say circle 2, whatever you want to say, circle 2 minus circle 1, if you've got two circles that intersect. And that equation comes up nicely. So this is what we can say. So again, guys, this is noteworthy. Please put it down. This is noteworthy. You will hardly see this in your textbooks, but you may be surprised by the question. As you can see, this is a past exam question paper. And if it is so, it means it can come to haunt you if you didn't know. So obviously, guys, this is literally the way of answering 13.2.2. as opposed to just being, a way of solving for as opposed to just being the way of solving for the points of intersection. Yes, we used it as a means to an end, but I just wanted to show you guys that sometimes in your quest to solve something else, you may find yourself bumping into the correct answer without noticing. Because the moment you get stuck with why, most students would stop and just submit, because they would be out of time trying to figure out what am I going to use, and only to find that you've just answered the question without noticing you did. So these are some of the things that you end up getting if you have a proper strategy. So please understand maths, guys, rather than to go through the motions. As you can see, you will find questions that you probably did not see before, and on materials that you may have not been taught before, but just your strategy and knowing how to play your game mathematically, you end up with the right answer. And this is the essence of attending classes, guys. You get skills, you gain insight. Then the subject becomes much easier to approach. I hope, guys, you learned something through this question. I know this is a question you can answer in 20 minutes, but my purpose here is to teach, guys. Since we could not have a lesson, which normally is an hour long, and of course we tend to go a bit longer when we're revising for exams. So this is essentially, guys, the work that I could produce just to keep you going. Please note this thing that I've shown you, that if you are to look for the equation of the common chord, you simply just take the difference of the equations of the two circles intersecting, and that will land you right into the proper equation of that common chord. As you would see that if we try to approach it the standard way, we end up stuck without knowing how to find our C. So that's the most important, guys. So please note this. Also for you as a student to basically consider, I would just say consider how to find the length of the common chord. Right, that's another note to take down, okay? Consider how one would find the length of the common chord. These are questions that can actually haunt you if you don't know your stuff. And unfortunately, it is demoralizing to find yourself struggling to answer those questions. All right, great stuff. Now, just some extra notes. Extra notes. These are things, guys, for those who will be sitting for the NBTs. Remember, these things always come at you. Now, when we talk about a straight line, y is equal to mx plus c. This is now based on straight line equations. Now, what do we know? When the gradient is positive, when m is greater than 0, and c is also greater than 0, we know that the x-intercept is always going to be less than 0. In fact, let me just say it implies rather than to make it a conclusion. So please note this thing, that on any straight line equation, when the gradient is positive as well as the y-intercept, it means the x-intercept will be negative. This is something that needs to come to mind, especially when handling hypothetical equations but trying to solve a problem. You will need this. Now it also follows that when m is less than 0 and c is less than 0, this implies that the x-intercept is also going to be less than 0. Right? When the gradient of a straight line is negative and the y-intercept is basically negative. Perhaps maybe I should have explored this before we explore the other one. Let's just say when the gradient is greater than 0 and c is less than 0, we know that the x-intercept is going to be greater than 0. Now, what I want you guys to pay attention to is the end result, because this is what kills a lot of students. They don't get this. When the gradient is less than 0 and the y-intercept is also less than 0, this implies that the x-intercept will also be less than 0. Right? Right. Likewise, when the gradient is less than 0 and the y-intercept is greater than 0, it implies that the x-intercept will also be greater than 0. Now, these are things to note, students. They are not clearly stated in textbooks or study guides. But in NBT-related questions, the fruits I have just given to you may prove very useful. So this is how you sum up a lot of studying, a lot of practicing, because you will know that on a Cartesian plane, when you draw these graphs, they only work this way. So what I would say here is that draw the graphs to explore this truth. Right? Draw the graphs to explore the truth. Because if you draw the graphs such that this is the case, you will then start to understand why it only works this way. So knowing how to graph these on the Cartesian plane is very useful as well, because it helps with our critical thought process. Anyway, guys, I don't want to make this video too long. As we said, we normally have, hourly lessons where we discuss, issues that are important to perhaps understand fully. But when we solve problems, we sometimes, take it a bit longer, because the idea is to just practice together. Of course, trying to inject the insights as well into these problems, knowing exactly what concepts underlie those tricky portions of the questions. I do hope you have learned something, and please, guys, take the notes seriously. Don't just rewrite notes on the textbook and think that is notes. If you don't understand, yikes, it's more like transcribing the textbook. But when you start to notice things not stated in the textbook, but rather implied by the whole process followed in understanding that concept, those are notes, okay? Refrain from writing the textbook back, hoping that you're going to remember. You won't. Again, guys, this is a note that I would rather you also internalize and ensure that you understand. Always try to find explanations as to why. As I said here, why is the common chord of two circles intersecting at two distinct points? Why is it perpendicular to the line that joins their centers? You can see that few constructions give us a kite. And we know that that chord, the common chord, together with the line that joins those two centers, they literally become the diagonals of that kite. And so they should be perpendicular. And again, this just falls nicely into the properties of a kite. So these are the things, guys, that I would rather you note rather than just solving the problems. At the same time, learn how to write answers in a manner that is convincing. This is your work, not somebody else's. That way, you will always be authentic. You will always be innovative. You will always be flexible, and that means you will always measure up to whatever requirement you will come across in the near future, be it as a professional or as an academic or whatever you choose to become. Otherwise, good night. I'll see you on tomorrow's lesson. Ciao.